Welcome everybody to this tutorial on abstract classes and interfaces. So what are abstract classes? Well, an abstract class is a template definition of methods and variables of a class that contains one or more abstracted methods. So what exactly does this mean? Well, it means we're creating a class that is used to have definitions for methods and variables, but is not meant to create an object. It is meant to be a blueprint for other objects. Let's take a look now at interfaces. An interface, in Java at least, is a blueprint of a class. So let's take a look at what these are. Well, first we have our abstract class. So here we have an animal. The animal has an age and a name, which are being stored in an integer and a string. And it has two methods. An eat method, which is void since it will output something, as well as a sound method, which will also be void since it is going to output something. However, next to the sound method, you'll notice in the quiggly brackets that we have a label that says it is abstract. The reason for this is because the sound method is not defined within the animal class. It is something that must be defined by the classes that inherit from animal. The purpose of this is because animal will never be used to create an object. Since it is abstract, we cannot create an object from it. We are instead using it as a blueprint for other animals, for things that need to be included in order for them to work. So you'll notice here that cat, dog, and horse all inherit from animal, and each of them will override the sound method and replace it with something else that is applicable to each of the individual classes. A cat will probably use meow, a dog will use ruff, and a horse will use neigh. There is no reason to define this within the animal since there is no default sound that exists between different animals. Methods such as eat or variables such as age and name are standard between them because of the fact that they do not change between animals. Next, let's take a look at interfaces. An interface works similarly to an abstract class, except nothing will be defined within the interface. Here we created an interface shape, and in shape we have three methods. The three methods are getArea, getParameter, and toString. Now, one of the big differences for interfaces you'll notice is that we did not define any variables. The reason for this is because you cannot define a variable in an interface unless it is going to be a constant. Therefore, you cannot change the value. Since we have no constants between shapes, we are not going to define any variables. Now we've created three other classes here, rectangle, triangle, and circle. These three will inherit the interface shape and will then override each of those methods, implementing one that is appropriate for the given shape. A rectangle will override getArea by using length and widths, same with perimeter. And finally, the toString method will use something that looks at the length and the width. You also notice that the variables that are within each class are different. Rectangle will use length and width, triangle will use base and height, and circle will use radius and width. This is one of the reasons why I'm choosing to use an interface for this instead of an abstract class. An abstract class is generally used when you have elements you already know will be similar between your classes. Since the only thing similar about these classes is that they should implement the same methods, we are going to instead use an interface. When we explore polymorphism, we will also look into why interfaces are incredibly useful. So let's take a look at what are the differences between the two. First, keep in mind that both of these are superclasses that cannot create objects. So they will be inherited from, however, they will not ever create objects on their own. For an abstract class, we will use extends to inherit from it. This is due to the fact that methods and variables will be defined within the abstract class sometimes, so we will be extending it. An interface, instead, will use the keyword implements to inherit from. This is different because of the fact that we are instead saying that all methods within an interface need to be implemented into the class I am currently using. You can only extend from one abstract class at a time. So for instance, if I have two separate abstract classes, I cannot choose to inherit from both of them. You are only allowed to extend from one class. Implement, on the other hand, can be taken from multiple interfaces. So for instance, let's say I have 3 different interfaces that I want to implement into one class. I can implement all 3. An abstract class can use instant variables and define them. An interface, on the other hand, can only use constants. This means that no matter what, you cannot change them within your subclasses. The methods within an abstract class can have a code body. This is completely fine, and they will be inherited with said code body into the next class. An interface's methods will never have a code body. You are not allowed to put anything within the method of its interface. An abstract class, to have methods that have no code body, simply needs to define them as abstract and then leave the code body blank. These will be inherited into the classes that extend them, however, they must then override them and replace them with something applicable to the current class. And finally, both of them do not include constructors. This is because we cannot create objects out of them. Let's take a look at coding an abstract class and an interface. Okay, so first let's take a look at an abstract class. Here we've created an abstract class called bank account. You'll notice in order to make it an abstract class, I had to put abstract in front of the class that we normally would have done in any other class. Next up, I'm going to create any state variables or any core variables that I need for my class. In this case, I have an account total, since all bank accounts will need account totals. Within there, I have a withdraw method, which all will inherit. This one takes in the amount of money that is going to be withdrawn, checks if the account has enough money. If it does, it will withdraw it and return true. If it doesn't, it will return false so that the code knows whether or not the withdrawal was successful. Deposit does not have the same check, but will simply add money to the account total. Get balance will give you the account total. And finally, we have an abstract method named toString. The reason this is abstract is because this method will be different between all different accounts that bank account is going to inherit into. Making it an abstract method means that all other classes will need to override this method and give its own interpretation of what the toString method is supposed to be. So let's take a look at checking account. Checking account is going to extend bank account. This is similar to what we've done before in inheritance. This time, though, instead, we are going to be taking from an abstract class which cannot create an object. Since I'm creating an object in this one, I'm going to make sure I create a constructor which will take in the amount of cash the checking account will have when it initially opens. Finally, I'm going to override the toString method by putting @override. This will specify to anyone coding that this is an override method. It means that the original method's functionality will not be used anymore and it will still be overrode with what I am using here. In this case, the checking account followed by its balance. Now let's take a look at savings account, which will also extend from bank account. In this case, I'm going to create more variables, in this case, an interest rate. I'm going to make sure that I have a constructor. The constructor is going to make the amount of total cash, as well as I just realized I am also going to make this.interest rate equal to interest rate. This will allow us in order to set the interest rate for the savings account as well as the amount inside of the account. I'm also going to have additional methods besides the ones that were in my abstract class, including gain interest, where I will increase the account by the amount of interest. Next, we'll have a method to set the interest rate, as well as one to get the current interest rate. Finally, I will have an override for the toString method to show the savings account balance after the string savings account. Now let's take a look at interfaces. So here's an example of our interface. We're creating an interface called shape, which has 3 methods inside of it. You'll notice, unlike my abstract class, I did not have to write abstract in front of it. Instead, I wrote public. You'll also notice that there are no bodies to any of these methods. That is because these methods are not going to be given any default values in any way. They are all considered abstract. Interfaces cannot contain anything besides abstract methods. You also notice I have no variables since I have no constants that I'm going to want to keep between shapes. We have our 3 shapes that we looked at before: triangle, rectangle, and circle. I am going to create the variables in each of these shapes that they are going to need, whether or not it's base and height, length and width, or radius. I'm then going to use a constructor in all 3, which will assign values to those variables. which is the same in all of these. However, they will be assigned to different variables since each of them are keeping different variables. Finally, all three of them will override each of the methods from my original interface, including getArea, getPerimeter, and toString. They will also all have their own versions. The circle will use r squared times pi, as well as 2r times pi. The rectangle will use length times width, as well as 2 length plus 2 width. The triangle will use base times height divided by 2, as well as returning 0 for the perimeter, since we don't know what the perimeter will be of the triangle based off the base and height. And finally, we'll have a toString method where we return the 2 dimensions we have along with the name of the shape. You'll notice that on all of these, I overrode each and every method. This is because you must do this for all abstract methods from your interface, otherwise your code will error out. If we choose to run these shapes, you'll notice that I have created 3 shapes here: a rectangle of a length of 10 and a width of 5, a triangle with a base of 15 and a height of 4, and a circle with a radius of 5. If I use system.out.println, this will print out my toString method, as well as, since I am printing out getArea and getPerimeter, I will have each of those values as well. That concludes our lesson on abstract methods and interfaces. Thank you for watching and have a great day.